Hi everyone. So today we're going to be going over another incline plane question. This one is Roger is pushing a box full of 30 wigs up an incline of 25 degrees. Mu is 0.4 with a force of 160 newtons. This causes the box of wigs to accelerate up the incline at 0.2 meters per second. And the question is to calculate the mass of each wig. So let's get started with the setup. So first thing we want to do is to draw a diagram of what's happening. So if that's the incline, that's at 25 degrees, and then we have the box of wigs and Roger who is pulling down. Next, we want to draw a free body diagram of all the forces acting on the box. So we have Fg and we have Fn, like that, and then the force of friction, which is going to be opposite to the acceleration, and the F pull force. Next, we want to draw a vector addition diagram. So we would draw Fg and Fn like this, and the force of friction, and F pull. It's going to start here and go all the way, extend up here. And then to close up this loop, we want to draw F net, which is going to start here and end at the head of the last vector, which is F pull. And of course, we want to just line up the angle with the angle on the diagram. So that's 25 degrees right there. All right, so let's go ahead and start our first question. So this one's asking, calculate the mass of each wig. So note that mass is a component of each one of these forces. So it's of force of friction, Fn, and it's contained in Fg and Fnet. So what we want to do is to come up with an expression that has one of these components in them. So let's use the F pull component. So if we look at F pull is made up of the force of friction plus this midsection here, and plus F net. So we can write an expression like that. So that contains both F of friction and F net, which both contain mass. So if we write that, we get F pull is equal to the force of friction, which is F friction, plus, remember this midsection right here. So this is still a right angle triangle, this part right here. So Fg, Fn, and this section right here. So let's just call this section A and solve for it. So if we look at this, A is opposite to this angle and Fg is the hypotenuse. So we can come up with this expression, which is sine of 25 is equal to the opposite, which is this part, which we called as A, all over Fg. So solving that, what we get is A is equal to Fg sine 25. So we can just grab this and put this over here. So it's going to be F of friction plus this section, which is Fg sine, I'm just going to leave it as theta, and plus F net over here. All right, so next, what we want to do is to break them down into their components. So remember, F of friction is just mu times Fn, and I'm sure everyone knows this by now. Fn is equal to mg cos theta. So we can write that, mg cos theta, plus Fg, which is mg sine theta, and then plus F net, which is just MA. All right, so next thing we want to do is to factor out the M, because that's what we don't know, and that's what we're trying to solve. So if we get that, what we get is F pull is equal to M, and then we factor M out of here, we have mu times G cos theta plus G sine theta plus A. And now, technically, we only have one variable, right? So we do know what F pull is. That's given to us. Mu is given to us. G, of course, We know that, and theta is given to us as well. Same thing over here, and acceleration we do know. So good, we're left with one variable, so now it's just a matter of algebra. So let's just go ahead and solve this. So all we need to do is grab this big chunk and divide it by f pull. So our expression for m is equal to f pull all over mu times g cos theta plus g sine theta plus a. All right, so now we can just go ahead and plug in the numbers. So what we get is 160 newtons all over 0.4 times 9.8 meters per second squared times cos 25 plus 9.8 meters per second squared sine 25 plus 0.2 meters per second squared. All right. So I'll go ahead and calculate that. So I get 160 over 7.894, and that is equal to 20.26. So it's 7.5, so I'll just round it to 8 kilograms. So note that this is the mass of all the wigs added up together, but the question is asking what is the mass of each individual wig. So since there's 30 wigs, you want to actually divide this by 30 and get the mass of each individual wig. So if I do that, I get 0.6755, so I'll round that to 676 kilograms. So approximately 676 grams. That is your final answer. Okay, thank you so much for watching. I hope this helped. If you have any questions, leave them in the comments below. And if you also want me to do other physics questions, leave them there as well. Thank you.